Okay, so here we're going to take some time to go through the answers to the formative assessment practice quiz. So the very, very first one that you had to do was write the electron configuration longhand for germanium. And I'm sorry, not sorry, it was a big one. So you should have identified that germanium had 32 electrons. You should have identified that the electron configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. When you write the orbital notation, it's arrow up, arrow down, all the way across in the 1, the 2s, the 2p's, the 3s, the 3p's, the 4s, the 3d's. But when you get to the 4p, it's arrow up, and then we have one blank one, okay? It's got to be that way. Any questions about that particular one? Okay. Next one, you are asked to write the shorthand notation for the element nickel, okay? And so the way I see it on the periodic table, nickel has 28 electrons. So nickel is in the fourth row of the periodic table. The noble gas that is in the row above it, the third row, is argon. So I'm going to take argon as my noble gas here. And I know that argon has 18 electrons. It ends 3p6. So after 3p6 would come 4s2. And then after 4s2, we would go into 3d. And because it's got 28 electrons, I count over 1, 2, 3, 4, 5, 6, 7, 8. And it looks like it's going to be 3d8. So then in the next case, let's see, 1, 2, 3, 4. Yep. So now when I write the orbital notation, I would still write argon. I would write 4s and 3d. Just like we've done in the past. I would put the orientation bars in. And then I would use my arrows. So arrow up, arrow down for 4s2, arrow up, arrow up, arrow up, arrow up, arrow up, arrow down, arrow down, arrow down for 3d8. Any questions about this particular one? Okie dokie. All you had to do in the next three was identify what is wrong with them. So if I'm looking at this particular electron configuration, 4s, arrow up, arrow down looks good. 3d, all full, arrow up, arrow down looks good. 4p, here's our problem right here. In this case, there should be an arrow up in the last orientation. And so what I'm looking for you to say is something to the effect of you have to add an electron to each orientation before you can double them up. Something like that. And if you wanted to put the rule in there, by all means, go ahead. Or the rule name. I'm not going to be too critical about that or too fired up about that, in large part because I'd rather you be able to tell me what happened. Okay. Next one, krypton. 5s got 2 arrows, arrow up, arrow down. 4d, it's got 10 arrows, looking good. Arrow up, arrow down, arrow up, arrow up. Oh no, this is our problem right here. So in this case, you should be telling me that you have to have electrons. So I'm going to put in parentheses arrows of opposite spin. In each orientation. A person could also say something to the effect of, you can't have 2 arrow ups. Or you could say it has to be arrow up, arrow down. but that's really what we're getting at is the spin. And then in the last one, 1s2, yep, arrow up, arrow down, 2s2, yep, arrow up, arrow down, 3s2, weird, because it should go 2p and then 6 and then 3s2. So this and this need to switch places. And I think that the best way for me to describe that is you have to fill lower energy levels first. So you have to fill lower energy levels first or something along those lines. Any questions about this? All right, next thing we have to do is determine number of valence electrons. And the way that we go about determining number of valence electrons is we look for our biggest energy level. And our biggest energy level, in this case, in the first one, is the 3s energy level. The 3s energy level has 1 electron in it. So we're going to say that this has 1 valence electron. In the chlorine, we are going to see that there is a 3s and a 3p. Okay, 3s and a 3p. In that case, I'm going to simply add my electrons together in both those energy levels. So 2 plus 5 gives me 7 valence electrons. And then lastly, for boron, I see that the 2s, 2p. So that's my biggest energy level there. So I'm going to add the 2 and the 1 to give me 3 valence electrons present there. Questions? So far, so good. Wonderful. Now we're going to look at some photoelectron spectrum data in an effort to identify an element. And so the first peak that I see has 2 electrons. So for going from left to right. So we're going from left to right. So this tells, and my nucleus is there. So that tells me this is going to be a 1s, and there's 2 electrons there, so it's going to be a 1s2. The next one, my next peak is a little bit further away, so that's going to be a 2s, and there's 2 electrons there, so it's going to be a 2s2. The next peak is a little bit further away, so it's going to be a 2p, and there's 1, 2, 3, 4, 5, 6 electrons there, so it's going to be a 2p6. The next peak is even further away, so that's going to be a 3s, and there's 2 electrons in there, so it's 3s2. And the next peak is even further away, and so that's going to be a 3p, and that's going to be a 3p1. So when I write my electron configuration, it's going to be 1s2, 2s2, 2p6, 3s1, and the element on the periodic table that ends its electron configuration with 3s1 is aluminum. Pardon? Sorry, 3p. Yep, you're right. Oh, boy. Oh, geez. That's a 3p, 3s2, and then 3p1. Oh, man. Which is still aluminum. I just didn't finish the thing. Wow. Nice catch. Air 5. Okay, all right. Moving on. Cation or anion? Remember, cations are positive. I wore my cation shirt today. Okay, no, not funny. All right. So, calcium is a +2, making it a cation. It loses electrons. And when it loses electrons, this time it's going to lose 2. Nitrogen is an anion. It's got that -3 there, so it gains. And in this case, it gains 3 electrons. Questions about that? All right, then. So here we go. We have nickel. And when I locate nickel on the periodic table, I see that nickel has, let's see, what does it have? It does 28 electrons. It's got a +3, so it's going to lose 3. So that brings it down to like 25 electrons. So when I write the electron configuration, I'm going to write one real quick once here. So I see nickel, and then I see argon is the noble gas above it. So I'm going to do this, argon, and that would be like 1s2. No, not 1s2. That's silly. Argon ends 3p6, so it's going to be 4s2, 3d. Let's see. Well, yeah, but it'd be 3d8 if it wasn't an ion. Okay. Now, it's going to take electrons from the 4s first and then from the 3d. So the final answer here is going to be argon 3d 7. So it took 2 electrons from the 4s and then 1 from the 3d. So when I write my electron configuration there, argon 3, 2, 4, 5, D, 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 orientation bars, and then I'm going to have a 7, so it's going to be 1, 2, 3, 4, 5, 6, 7. All right, selenium is a -2. So if selenium's a -2, and I see selenium on the periodic table's got 34 electrons, and it's a -2, it's going to gain 2. So that's going to become 36 electrons. What? No, you're good. So 36 electrons. So if it has 36 electrons, if I were to write it as it was before, selenium is in the, let's see, 4th row. So the noble gas that comes before it is going to be argon, and it would be like 4s2, 3d10, 4p4, something like that. Right? Did I do that right? Am I doing selenium? Yeah, I'm doing selenium. Okay. Now, the problem is that it's gained 2 electrons. So if it's gained 2 electrons, it becomes 36. And the element that has 36 electrons on the periodic table is krypton. So really, all you have to write here is krypton. Yes?
In the test, do we have to put the old one?
No, I'm just trying to, and the reason why I'm showing the old one is so that when people are studying, or if they weren't sure about this, I'm trying to show where things came from. And so then with your orbital notation, still krypton. Yes, sir.
So for the cation above, when it's losing 3 electrons, where does that go?
The question is, when an ion loses, or when an atom loses 3 electrons, where do they go? The issue is, and I've already said this once, but I'm going to say it about 700 more times this year, this class, this school year. Atoms will gain or lose electrons in an attempt to get a more stable arrangement of electrons. And they do that by bonding with other atoms. So when we say an atom loses an electron, 1 or 2 or 3 electrons, those electrons are then picked up or gained by another atom, like in this case, selenium maybe, might pick up an electron or 2 to become more stable. And we're going to spend an entire unit talking about it when we get back from Christmas break. All right. Any other questions? Oh, it's krypton, not K. That'd be a wholly different element. All right. Next one. Ground state or excited state. So here's what I'm seeing. I'm seeing that in the case of the first one, S can hold 2. It's got 2. S can hold 2. It's got 2. P can hold 6. It's got 4. There's no electrons coming after it. So I'd be pretty comfortable saying that we are in the ground state. I don't know what letter that was. Ground state. So if it's in the ground state and we're asked to figure out the elements, I would take 2 plus 2 plus 4, which is 8, which gives me oxygen. Okay. Next one. The S can hold 2, and it does. The S can hold 2, and it does. The P can hold 6, and it's got 5. So far, I'm not too upset about it. But then the P here can hold 1. So that tells me that, or it can hold 6, but it's got 1. So what it tells me is that an electron from the from the P5 jumped up to another energy level, and that means we are in the excited state. And then if I'm going to figure out the element itself, I would take 2 plus 2 plus 5 plus 1. 2 and 2 is 4, plus 5 is 9, plus 1 is 10. So that would give me neon. Any questions about this business here? Excellent. I highly suggest that you take some time this weekend, Sunday at some point maybe, to just re-look at this formative, because the assessment that you're going to take on Monday is the exact same format. So I think that you should think about it for a little bit before you take the quiz. Have a wonderful weekend.